Okay, last go around, folks. No enrichment packet today. Okay, thank you for your cooperation last week on that. Okay, square root of 245. 245, not a perfect square. Okay, so it's probably not gonna divide by 225. Okay, how about 196? Nope. How about 169? Nope. How about 144? Nope. Got to be patient with a big number like this. 121. No, 100's not going to work. Okay. 81. Nope. 64. Nope. 49. No. Oh yeah, bit cha-ching. So I rewrite that as the square root of 49 times the square root of 5, and that becomes 7 whole square root 5. 9, gee, that's a hard one. 9's already a perfect square. It's equal to the whole number 3. 7, well, you can divide into your 7, but I don't think you're going to be able to divide it by 4, which means it's already in simplest form. Okay, you can't bring any whole number factors out of that, other than 1, which is stupid to do. Okay, square root with variables. So focus on this. The variables are easy to do. You need to focus on square root of 18. Okay, 16 won't work, but I can divide it by 9, so I rewrite it as the square root of 9 times the square root of 2. So that would be 3 whole and 2 inside. Now, x is even, so I don't put an x in there, but I cut it in half. It goes x to the third. Done, done. Okay, that's odd, so what I do is I put a y in here, and that allows me to take it down to second power. Half of 2 is 1. Y to the first power, you can also just put y. 13's odd, so I put a z inside, factor of z. Then that allows me to take it down to 12. Half of 12 is 6, z to the 6. Simplified. Okay, multiplication, 1, 2, 3. First I take 2 times 6, that's 12. And then I take the square root of 2 times the square root of 10, which is the square root of 20. And then 20 is not a perfect square, so then I divide into the 20. I'm pretty sure 20 will divide by 4. So you remember your whole factor of 12, okay? You can't forget that, because you rewrite that as the square root of 4 times the square root of 5, but the square root of 4 is 2 whole. And then I take 12 whole times 2 whole, which is 24 square root 5. Okay, addition. Okay, that's totally different than multiplying. It's not even comparable. Okay, those have to be the same. So I need to rewrite the problem so the numbers under the square root are the same. So you got 5 square root of 27, 7 square root of 192. So 27 is not a perfect square, and you can't divide it by 25 is a decimal. 27 divided by 16 is a decimal. Now 27 divided by 9 is 3. Okay. Now, you can't just write square root of 9, square root of 3 without dropping your whole factor of 5. Okay? Now you can write square root of 9, square root of 3. The 5 doesn't just vanish. Okay? And then 5 whole times 3 whole is 15 whole square root 3. So that term has been rewritten as 15 square root 3. Okay, now 192. Well, by 169, I can kind of no, that's not going to work. Okay, 144, nope. 121, no. Can't divide by 100 unless it ends in 2 zeros. Okay, so try 81. 64, cha-ching. Drop your 7, rewrite that as the square root of 64 times the square root of 3. So that becomes 8. So 7 whole times 8 whole is 56 whole square root 3. Now you rewrite that as 56 square root 3. So now I have the same square root. So I have square root 3, and then I add 15 to 76, and that's 71 square root 3. Okay, now we get into the geometry slash trigonometry portion of this with the right triangles. Okay, we need to solve for x and y. Okay, now again, these special right triangles, again, you have to use a proportion to solve for each variable. Okay, but again, I'm not doing this stuff because these triangles mean I don't have to. So 36 over x, 36 over y. Okay, now label your proportions. Okay, so the hypotenuse is always proportional to 2. Across from the 60 is always proportional to the square root of 3. Across from the 30 is always proportional to 1. Okay, now I'm ready to rock and roll. 36 is proportional to square root of 3. X is proportional to 1. And over here, square root of 3, and y is proportional to 2. Okay, now cross products. 36 times 1 is 36 divided by the square root of 3. Well, that's a problem. We need to write square root of 3 on top, and that allows me to get rid of the square root, and now it's 3 whole. So 36 divided by 3 would be 12 square root 3, and that's equal to x. And the same type of thing happens here. 36 times 2 is 72 divided by the square root of 3. We bring square root of 3 to the top, and that allows me to eliminate the square root on bottom. So 72 divided by 3 is 24, square root of 3, and that's y. Okay, and those are your two answers. Okay, now the same thing's going on with the 45, 45, 90. It's different proportions, but same difference. Okay, you got 4 over x, 4 over y. So the hypotenuse is proportional to not 2, but the square root of 2. Then the other sides are proportional to 1. Okay, so 4 is with 1, x is square root 2. 4 is 1, and y is 1. That's an easy one. Now the other one, again, I just write down the product of the expression. 4 square root of 2 divided by 1 is 4 square root of 2, and that is equal to my x. And over here, it's going to be 4 divided by 1 is 4. So 4 equals y. Okay, find the following ratios: sine, cosine, and tangent. So sine's O over H, the cosine's A over H, and the tangent's O over A. So I have to use the Pythagorean theorem then to find out what my sides are, because I know two sides, okay? I know my hypotenuse is 12. Here's the theta. That's your opposite, and your A is unknown. So A squared plus O squared equals H squared. So my A, don't know it. My O is 8 to the second, and my H is 12 to the second. So that gives me 64, and that's 144. So these are on different sides. Remember, if they're on the same side, you add, but with different sides, you subtract, undo the plus. Okay, that ends up being 80, and then I find the square root of 80, because x, the number, and it's almost 9, but not quite. 8.94 is my A. So O, it's 8, H is 12. You don't need to reduce it. It's reduced to 2/3, but we don't need that. So A, 8.94 over 12, and then O is 8, and A is 8.94. Okay, find the 3 side lengths and angle measurements. Okay, down there for you. Again, you're going to have to use the A, O, and H because, and you're going to use proportions, but you have to use the A, O, H, sine, cosine, tangent, because it is not this, it's not that. You see that 40 right away, you know it can't be. Okay, so H, don't know it. I use the 40 degrees here. And that's going to go in the numerator. And that's my O, which I have 12 for, so O is 12. And A, don't know it. Okay, so the two sides I don't know are A and H. So I'm going to find A here and H here. You're going to need O in both of these because we have that value of 12. So A and O would be the tangent function. That's OA. H and O would be the sine function. That's OH. You got to get these placed right. It's not AO. You put AO, you're done. Okay? You're just going to end up with a messed up answer. O is 12. And here my O is going to be 12 as well. Okay, I cross multiply and divide. Now cross diagonal from the A, I have tangent 40. Here diagonal from H, I have sine 40. Then 1 times 12 is 12. 1 times 12 is 12. So I divide 12 by the tangent of 40 degrees, and that tells me that that side is 14.330, which is 3. That's your A. Again, that H better be higher than both of them. So 12 divided by sine 40 is 18.67. Again, the H has to be the highest. Angles, you got 90, 40, and then 180 minus 90 minus 40 is 50. Nice. Triangle's been solved. Okay, and finally, 5 sides. Okay, so again, finding the area of a regular polygon, I use S times N times A divided by 2. So the side length 16. N is the number of sides. It's got 5. Okay. Now A is the apothem. Okay. My job is to find the apothem. Okay. So I've done a couple things. I've split that down here. That's 8. Okay. I'll put that down below. You know, that's 8. And I have a right triangle because that's a right angle. The apothem's is always perpendicular to one of the sides. Okay. All right, now I'm going to need to use the AOH, okay, with the ratios. And I needed degrees to fill that in. And remember, I'm finding the A. And I don't care about the hypotenuse, so I'm always going to know the O. I know the O is 8, okay. Okay, so we need some degrees to go in here. So we take 360 degrees divided by 5, but then can't forget the next part. You got to divide it by 2. Dividing it by 5 is just an angle, would be this. Okay, if I made another that, it'd be the two sides together, but I'm splitting in half. 36 degrees, okay? So 36, and then A and O is the tan function, tangent. And then again, tangent is OA. You can't get that mixed up. Now we're solving for the A. Get the O out because you replace that with the value of 8. Okay, A is diagonal from tan 36. So we're dividing by the tangent 36 degrees, and 1 times 8 is 8. So 8 divided by tangent 36, I got 11.01. I'm going to put 11 there. It's close enough. So 16 times 5 times 11 divided by 2 is 440. So that's 440 square feet. Okay, work on the other packet then.